Hello guys, I'm Genius. You're welcome to my channel once again. Today we're going to be looking at chemistry and I'm excited like an atom and I hope you are. Alright, so today we're going to be looking at how to write and name inorganic compounds. I'm precise in using the word inorganic because the method of naming compounds, inorganic compounds, is different from that of naming organic compounds, even though we use the same system, the IUPAC system. Yes, but the methods are different. And just in case you want me to talk on the naming of organic compounds, you can drop that in the comment section and I will attend to them. Are we together now? So from here, we're going to be looking at empirical and molecular formula as well. So this video is loaded for you. Moving further, we're looking at writing and naming inorganic compounds. Now, the first thing you need to know about writing and naming organic compounds is you need to understand valency. Understand what? Valency. All right. Valency. Now, valency in chemistry simply means the combining powers of elements. Yes, the combining powers of elements. We have learned that the atoms of elements have the ability to combine with one another to form, or to combine with different atoms to form compounds. Are we together now? And so whenever they want to combine, they use their valency. And since we have said valency is the combining power, it means that if any element rather does not have valency, then it can't go into chemical combination. And so if you have valency, you can go to chemical combination. And I want to bring to our knowledge that valency is nothing big. It is just number. Valency is what? Is a number. Are we together now? So when I ask you what's the valency of an element, I expect you to give me a number. Are we together now? So most students will not actually understand valency by this definition I've just given. Are we together now? And so I'm going to try to make it more simple for you to understand. When we talk about valency in practice, valency is just the number of electrons that an atom of an element will either gain or lose to be stable. I come again. Valency is the number of electrons that an atom of an element will either lose or gain to be stable. We know that in chemistry that atoms of elements are always after being stable. And stability, talking about stability, we're talking about the duplet or the octet stability, where hydrogen having one electron and helium having two electrons, they only undergo duplet stability, while other elements undergo octet stability. And so if the atom of an element is not stable, it's going to either gain or lose electrons. Are we together now? So the number of electrons it gains or lose becomes its valency. Let's take for instance sodium. All right, sodium has the symbol Na. I know sodium is number 11. It has 11 protons. That's the atomic number. Mass number is 23. But we are after the atomic by here. Remember that for atoms are said to be electrically neutral because they contain equal numbers of positively charged particles and negatively charged particles, which are protons and electrons respectively. So if we say that the atomic number of sodium is 11, which will mean to say that the number of protons of sodium is 11, it also means that sodium also have 11 electrons. And if you look at the structure of sodium, we'll start with the nucleus, and then we have the K shell. We'll fill in 2 electrons, and 9 will be remaining. Then I draw another shell, the L shell. Then remember, this shell can contain maximum of 8, and we fill it in. Okay, so this is 10. Then I draw the next shell, and I fill in 1. So this is 11. You can now see that sodium will actually require about 7 more electrons to attain octet stability, because it has only 1 electron in the atomos shell. Remember that the electrons in the atomos shell are called valence electrons. So sodium has only 1 valence electron. Are we together now? And so it will need 7, but however it can't get that 7, and sodium will rather give away the electron in the valence shell. That makes sodium to have the valency 1 because it lost or it loses 1 electron to be stable. Are we seeing that now? So the valency of sodium is what? 1. We'll be looking at oxidation states in subsequent videos where we can differentiate between who is losing or gaining by putting positive or negative charges. Are we together now? And so let us look at another kind of element. Let's look at oxygen. All right, oxygen is written by capital letter O, and the atomic number is 8, mass number is 16. So in the same way, atomic number is the number of protons. If the number of protons is 8, the number of electrons will still be 8. And so if I'm trying to draw the structure of oxygen, I draw the nucleus, then I have the K shell, I fill in 2 electrons. All right, now it's remaining 6. So I fill in this 4 and this 6, then here and here, and this what 8. You can see that there are 6 electrons in the atmosphere of oxygen, and so oxygen will be needing 2 more electrons to be stable, and so for that the valency will be 2, because it's probably going to gain 2 electrons to be stable. So for oxygen the valency is what 2. Are we together now? So you can see what the word valency is, and that is just what you need to know in writing inorganic compounds. Then the naming will be very easy. Are we together now? So in writing inorganic compounds, you just need the valency of the elements involved. Are we together? So let's quickly look at the combination between sodium and oxygen, and let's try to get the chemical formula of the compound formed between sodium and oxygen. Are we together? All right, so we're looking at sodium and oxygen. Sodium is capital letter what? N. N and small letter A, right? And oxygen is capital letter O. So for me to combine sodium and oxygen, I'm going to use their valencies. Remember, the valency of sodium is 1. I'll write it above sodium. The valency of oxygen is 2. I'll write it above it. The only thing I need to do is to interchange the valency. So it simply means that if you want to write the correct chemical formula of an inorganic compound, just get the valencies of the elements involved and interchange the valencies, and that gives you the answer. Are we together now? So I'm going to pick this valency of oxygen and make it the subscript of sodium, and then pick the valency of sodium and make it the subscript of oxygen. So that will end up giving me what? Na, this becomes what? 2, and then O, right? 1. We don't put 1. If nothing is there, it means that is 1. So this is the chemical formula formed between the combination of sodium and what? Oxygen. All right, so let's look at another example. Let us look at the combination between magnesium and chlorine and what? And chlorine. Magnesium and chlorine. Are we together now? What could be the possible chemical formula? Now, I'm also going to draw the structure of magnesium. Magnesium is number 12, chlorine is number 17. So it means that magnesium have 12 electrons in 12 electrons. So this is the K shell 2, then this becomes the L shell 4, 6, 8, 10. Then remaining what? 2. Are we together now? So it has 2 valence electrons. It's going to give us these 2. So the valency of magnesium is equal to 2. Now let's go for chlorine. Chlorine is the K shell, right? So this 2, and this is the L shell 2, 4, 6, 8, 10, 12, 14, 16, then this 17. This is the atomic structure of chlorine. So it has 7 valence electrons and be needing only 1 to be stable. So it's going to gain that 1. And because it needs 1 electron to be stable, the valency of chlorine is 1. Are we together now? So for me to combine magnesium and chlorine, I just have to bring magnesium, then write the valency above it 2, then bring chlorine, write the valency above it, then also interchange the valencies to give the subscripts I need. So since the valency of chlorine will become the subscript of magnesium, it becomes Mg, and then the valency of magnesium becomes the subscript of chlorine, becomes Cl2. And so this is the chemical formula for the combination between magnesium and chlorine. Are we together? All right, so we're going to be looking at another example. Bear in mind that the examples I've been giving so far is for binary compounds. In chemistry we have binary compounds and we have ternary compounds. Binary compounds are compounds that are made up of 2 elements only, while ternary compounds are compounds that are made up of what? 3 elements only. And in this video I've started with binary compounds, and then we're going to be looking at ternary compounds as well. So let me do one more example for binary compounds. And so for binary compounds, I'm going to write the combination between iron and let me say and oxygen. Iron and what? And oxygen. Okay. Now some elements usually have more than one valency. Yes, some elements have more than one valency. Examples are iron. Iron is Fe. The valency of iron is 2 and 3. Copper is Cu. The valency of copper is 1 and 2. Are we together now? Yes. We can also add some of them in the list. We have manganese. Manganese, we have 2, 4, we have 7. Yes, we have 2, 4, we have 7. Then we have for chromium. Chromium, we have 3, and then we have 6. And so some elements like this usually have more than what? One valency. Are we together now? Yeah, to add that, we also have carbon. Carbon is 2 and 4. Okay, so working with this, you have iron and oxygen. So I'll bring iron. Now that iron have 2 valencies, okay, 2 and 3. I'm going to solve the first one using valency 1, valency 2. So using what? Valency 2. I'll have the iron Fe. I'll write the valency 2. Remember that oxygen, the valency is 2. I've done that in the first example. So we interchange the valencies to give us the subscript of the respective elements. Are we together? That will give us Fe2O2. Yes, and this is the formula. But then you can simplify this. I'll talk about that more in the empirical molecular formula. We'll simplify this to cancel out 2. That will give us what? FeO. And this is the formula for the combination between iron and oxygen using valency 2. Are we together now? All right, let's do the next one. B, using valency 3. Using what? Valency 3. Now, using valency 3, we have what? Fe, then we use 3, and then O, oxygen. Also interchange the valencies to give the subscripts. Are we together? So you have Fe2, right? And then O3. Now, we can't cancel out anything because we don't need decimals, because 2 cannot go into 3 without any remainder. And so we will leave it this way. And so this is the chemical formula for the combination between iron and oxygen using valency 3. Are we together? So the next thing we're going to do now is to name these inorganic compounds. All right, so we're looking at how to name binary compounds. So far, I've actually taught you how to write the chemical formula for the binary compounds. Are we together now? And so we're going to be looking at how to name them. For binary compounds, there are no more rules. You just need to look at the compound you are given and then make sure that the first element you retain its name. Like sodium will be sodium, magnesium will be magnesium, iron will be iron. Are we together now? But then the second element, you are going to add the suffix IDE to it. You remove about 3 of the letters or so, and then you add the suffix IDE. So that means if you are looking at oxygen now, oxygen, to name it when it's involved in binary compound, oxygen becomes oxide. Yeah, chlorine becomes chloride. So you can see I'm putting this ide. So nitrogen, oxygen becomes nitride. Are we together now? Fluorine becomes fluoride. Yeah, sulfur becomes sulfide. Are we together now? And so just in case you are giving any of them to name is very simple. Are we together now? You don't need the valence. So to name this compound now, you have already shown how to write the formula. To name it, you're just going to say sodium will remain the same way. Neglect the subscript. So just write, so don't say sodium 2. Okay, yes. Just say sodium. Once your oxygen becomes what? Oxide. So that's what? Sodium oxide. Simple. Now magnesium, you write what? Magnesium. Then this chlorine becomes what? Chloride. So you have magnesium what? Chloride. Yes. You can see that you see magnesium chloride. Yes. And then look at iron. So this iron. Now, I'm going to be careful with this because look at this. If I write iron, you think I'll just say iron oxide, right? iron oxide. Then here also iron oxide. But there's going to be a problem here, because how do I differentiate between FeO and Fe2O3? This is where we have to add something more. Whenever the one of the elements involved in the combination has more than one valency, you must impute the valency you are using after the name of that first compound. Are we together now? Yes, you must write the valency in Roman numeral and in brackets. So what valency do we use for iron? Remember, the valency of oxygen was 2, this was 2, they interchange, you become Fe2O2, and we cancel it out. So the valency of iron here was 2. So you can guess the name of this compound now. So I'm going to write iron 2 what? Oxide. So take note of all the elements that have more than one valency. For you to name the binary compounds, you must make sure you include the valency you use. Are we together now? And in the same way, obviously, these three, this sulfate of oxygen actually belongs to who? Belongs to iron, while these two belongs to oxygen. So the valency of iron is what? 3. So it becomes what? Iron 3 oxide. So why this is iron 2 oxide, this becomes iron 3 oxide. Are we together now? Now, can you guess the name of this compound? This is hydrogen and sulfur. Alright, you can pause the video and give it a try. Okay, if you have done that, you see that this is what? Hydrogen. It will remain as what? Hydrogen. Sulfur will change to sulfide, so it becomes what? Sulfide. So this hydrogen what? Sulfide. I know this is a gas, the only gas that has the smell of a rotting egg. Yes. Are we together now? And some students usually find it difficult to name these compounds. You know, this CO and then this CO2. Some of them can call this carbon 2 oxide. No. Now, anytime an element is combined with oxygen and there are no subscripts, it tells us that they have been cancelled out, and therefore the valency of that element will be 2. Because oxygen will be 2. Yes, 2, 2, they will interchange and they will give you what? C2O2. So it will cancel out. So anytime oxygen is combining with any substance or any element and there is no substance, you know that the valency of that is what? 2. And so it means that if I'm looking at CO, it will be what? Let me clean this off. Okay, if I'm looking at CO, it's going to be what? Carbon. Okay, carbon what? 2. Carbon 2 oxide. Then CO2 will be what? Now remember, for how do we get to CO2? So you can see that this is carbon and this is oxygen. Now remember, carbon, I say carbon has 2 and 4, so using 4 is 2. Okay, so that will give us C, and this becoming here to give you 2. Alright, and O4. 2 here is 1, 2 here is 2. So have it as CO2. You know, this is what? Carbon 4 what? Oxide. And so you can name binary compounds now. Are we together now? Yes. Hope you are enjoying the video. Please make sure you like, comment, and share.